Hi everybody, in case you need some notes on just the law of cosines, we're going to start here on page 326 of your book. Law of cosines is derived from right triangles, so there's a little bit of essence of Pythagorean theorem. And the relationship for the law of cosines is the cosine of any angle that you select and its opposite side. So if you're looking at angle A, side A is opposite. So side A is the beginning and the cosine of A is the end. So let me start here. They were asking us to write it out three different ways. Once, as you can see at the end here, one's for angle C, one's for angle A, and one's for angle B. So I'm going to do it in that order. It's really the same formula, but it just isolates one side at a time. It's just a good pattern. It's an easy pattern to remember and one that you'll have to remember. You won't be given this. So if we wanted to isolate angle C, the pattern for the law of cosines means it would start with side C. So we'd start with C squared equals A squared plus B squared. Now this is not Pythagorean theorem because this is not a right triangle. Then you would always do a minus 2. That minus 2 is just in every version of the formula. Take those two sides that you just squared and use them unsquared, multiply them, and then take that times the cosine of angle C. Capital letters are used for corners or angles, and lowercase letters are used for the sides opposite. So we're just going to kind of replicate that pattern for each one. So if we want to talk about angle A squared, side A squared would be over here, meaning the other two sides, which are B squared and C squared, then minus 2, of course, BC, and then, of course, the last ending is the cosine of angle A. And for angle B, would start with B squared equals A squared plus C squared minus 2AC, finally, times the cosine of angle B. So I'm just going to run through a few examples, show you how to put it into your calculator, show you all the different versions, how do you use this to find a side versus how do you use this to find an angle, and when would you use the law of cosines? What do you need to know? Side, 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 angle, things like that. So here on page 327, we're not going to do all of these examples, but we are going to start here with problem number 4. Excuse me. So on problem number 4, it says, we can use a law of cosines involving non-right triangles or oblique triangles. So this is when you would use a law of cosines. Because of it's not as simple as just the cosine, so it's not really something you want to use all the time. So you're looking for a situation where you can't use your SOHCAHTOA or anything from the unit circle or anything that we already kind of know. So this is a non-right triangle application. We are looking for the length of the retaining wall from the diagram below. So it says a courtyard in Ghirardelli Square in San Francisco will be a triangular. Find the length of the retaining wall given the diagram shown below. So if we're looking for x, remember it starts with the side. So we're looking for this relationship. So we're going to start with x squared and use the other two sides within the formula. So I'm just going to write it out. So x squared equals, it does not matter if you choose 45 or 30 first. It's up to you. As we're adding and multiplying, so those orders don't matter. And then the pattern is to minus 2, and then take those same two sides, not squared, 45 times 30. And then finally, the cosine of the angle, which is 105. Hopefully that did not go off the page. Let me move this over. So that was the cosine of 105 at the end of this. When you put this into the calculator, it is x squared. So unless you are prepared to hit the square root key and enter this entire thing underneath there, you're going to need to take the square root at the end. You can type it in exactly the way you see it, 45 squared plus 30 squared minus 2 with the parentheses, cosine of 105. Remember, your calculator will automatically give you parentheses right here. And depending on the type of your calculator that you have on the operating system, sometimes when you hit the square root, you get a parentheses in the beginning. And that's how the calculator knows that all of that is under the radical sign. And some of you will have the operating system where the radical sign gets drug along and you can see that the square root is visibly there. The answer for this, they didn't say what to round to. Let's round to 2 decimal places. And so make sure you take the square root, check with your calculator, make sure that you're able to get the right answer. And if you're not, let me know and I'll help you the next time I see you. So this is 60.198. So we'll go 60.20 yards. So that's the way that you enter it if you are looking for a side. If you are looking for an angle, it's much different. So let's jump down here to problem number 6. Problem number 6 has a diagram over here, and we're going to have an issue with space, of course. You know how that works. We are not going to do problem number 7, so I'm going to kind of have to write into problem number 7, and you might have to as well, because we are going to not have enough space. And of course I have this line here. So number 6 says, the annual escape from Alcatraz Triathlon includes a 1.5 mile open water swim from the island to aquatic park. Due to the strong current, swimmers aim for a tower located 0.3 miles upshore from the aquatic park and 1.25 miles from Alcatraz Island. What is the angle between the course and the swimmer set and the actual course that they swim? So the picture is right here in case you have a hard time visualizing it. So we're looking for this angle. Right, so this is the direction in which they aim. So this is the 1.25 miles. And then the actual triathlon is supposed to be 1.5 miles. So that's the straight line distance from Alcatraz Island to the goal. And so we're looking for that angle. The distance between the aquatic park and the tower, of course, is 0.3 miles. So it's important to establish their position so that you know where the angle and the side are opposite. So we know that x and 0.3 are opposite. X is, of course, an angle, not a side. So if we're looking for x, you have to start with 0.3. I'm really struggling with the space here because this is going to take a minute. I'm going to move this down here. So we have, sorry, hopefully you're not motion sick. We have 0.3 squared equals, then you go along, same thing. The other two sides, doesn't matter if you do 1.5 or 1.25 first. Square those, minus 2 times 1.5 times 1.25. And it's going to end with the cosine of x. Order of operations is very particular here. Be careful with how you enter this into the calculator. All of this is stuck together. You can't just combine that with the first two numbers. It is stuck to the variable, which is the cosine of x. This is your coefficient for the cosine of x, and you must divide by that quantity in order to solve the problem. So this is 0.09. I'm going to write these out because it's important that we have the parts, because this is not, it's not just put it in the calculator and figure it out. 1.5 squared plus 1.25 squared, the sum of these two is 3.8125. Be very careful with just rounding. As you know, rounding in the middle of the problem is going to impact the solution tremendously. So minus, I would write down 3 or 4, probably 4, maybe 5 decimal places there if that's what you have available. Now this is minus 3.75 cosine of x. First thing you have to do is you have to subtract this 3.8125. Now I'm not saying you have to write it down, I'm just showing you what we're doing. We have to get that out of there so we can divide by that negative 3.75. So now we get negative 3.7225 equals negative 3.75 cosine of x. Now we can divide. And remember, we are looking for an angle. When you're looking for an angle, you're going to use an inverse. Some of you think the inverse is the reciprocal. The inverse is not the reciprocal. The inverse is how you find an angle. Now, I don't like to type, as you know, when you do this, you're going to get a very long decimal when you do the division. So this is gone. So I would put in the calculator, second, do your division, hit equals or enter, do second cosine, second ANS, which is right above the negative sign. That's going to take that decimal and reinsert it back in there. You should get 6.94 degrees. If you don't, you have trouble with that, let me know and I'll help you with your calculator. It's very particular how it gets entered into the calculator. Now for number 8. I'd like to take a look at number 8. I'm going back to a little geometry review here. What two sides of an isosceles triangle, have lengths 12.2 and 5.8? Why is there only one possible triangle in the situation? Now we're not going to do the angles. So if we think about this triangle, it's isosceles. So we have two options, where the 12.2 and is this matching, and then 5.8, or we have this version of it, apparently much smaller, where this is the 5.8 and 5.8, and then the non-matching side is the 12.2, but they're telling you there's only one possible solution for this triangle. If you recall from geometry, which is, I know, a stretch, the sum of any two sides, I'll say side 1 plus side 2, doesn't matter which one you're calling 1 and 2, has to be greater than, not equal to, greater than the third side, whatever side is left over. If that's not true, then you do not have a triangle. 5.8 plus another 5.8, that's 11.6. That's not big enough. So this triangle is not allowed. So the only one that's allowed is where the 12.2 are the equal sides, with the 5.8 being the third side. That's an important thing to realize. You can't just pick up any 3 side lengths and create a triangle. Just can't pick up any 3 sticks off a ground and have them be a triangle. It has to be in that kind of a setup, on relationship rather. All right, now we're on page 328. I'd like to take a look at number 9. Be prepared for anything, and by anything I mean that. I don't know if you'll Pythagorean theorem will be thrown in, regular cosine, regular sine, random facts about triangles, 180 degrees in a triangle, distance equals rate times time. Really and truly, anything means just that. So that's what we're getting a little bit here from number 9. We have 2 ships leaving the dock at the same time. They travel in straight lines, so the angle between them is 52.1 degrees. Draw the triangle so that it looks correct or not. That's up to you. I have a tendency to draw my triangles the same, so I don't know why, but I picture going this way. So here's my 52.1 degrees, and the ships are sailing away from the dock. One ship travels at a rate of 15.8 miles an hour, and the other ship travels at a rate of 12.16 miles per hour. This is why you need to know distance equals rate times time. We do not do law of cosines with rates. We need the actual distance. How far apart are they after 4 hours? Please be careful in your reading. Please read the entire problem. These have a tendency to, they're not hiding any information, but it's not always that obvious. So that means we have to multiply this times 4. I multiply the 15.8 times 4 to get the distance that they've traveled. So the 15.8 side, 15.8 times 4, this is 63.2. This is in miles. And then the 12.16 times 4 is 48.64. Also, of course, in miles. The question says, how far apart are they after 4 hours? So we are looking for the distance that they are apart. That's why I've labeled X. I feel like we're going to need some room here. Oh, hello. Sorry. I don't know what's happening. I don't want to lose part B. Again, space issue. So for part A, you can tell this is the law of cosines, hopefully. We're dealing with side, angle, side. So side, angle, side is law of cosines. Side, side, side is also law of cosines, and we will get into the details when we start having law of sines and it's mixed together. So for part A, trying to be strategic here, we have x squared equals 63.2 squared plus 48.64 squared minus 2 times those two numbers, 63.2 times 48.64 times the cosine of our angle 52.1. This is the kind where you can type it into your calculator, you can have the radical sign around the whole thing, but we get x equals 50.83 miles. Seems like 2 decimal places was our largest decimal, so that's why I went to 2. Now for part B. This is where we get anything goes. After 4 hours, they change direction and sail directly toward each other. If they maintain their same rates of travel, how long will it be before they meet? So we know the distance between them. We know how fast they're traveling. Again, distance equals rate times time. With the distance being 50.83, the rates being 15.8, which I don't know how far that ship is going, and 12.16, I don't know how far that ship is going. So we get 27.96 x equals 50.83. When you divide, it is 1.82 hours. Just because we're trying to make a proportion, you use the same letter. Obviously, they will not travel the same distance, but they'll have traveled the same amount of time when they meet. Hopefully this helps you a little bit to catch up. The assignment is right here on page 328. The assignment is the pictures, 11, 12, and 13. So page 328, 11, 12, and 13.